ForecastBroker, an open archive for hydrological forecast data by Eric de Rooij. The aim of the ForecastBroker is to provide an open and accessible way to store, search and exchange hydrological observation and forecast data. It makes use of well-known international software standards such as the Catalog Service of the Web, OpenDOP and NetCDF. Behind the scene, the ForecastBroker consists of a number of components that work together. Firstly, we have the storage containing all the data files and associated metadata files on the file system. All the data files are made accessible by the Threads server, which hosts an OpenDOP API and an HTTP download. A harvester process developed by Delft-FEWS goes through all data looking for new, outdated or updated data and creates metadata records in a catalog. We currently support two catalog services. One, GeoNetwork, and two, the Elasticsearch engine. Firstly, GeoNetwork hosts the CSW, the Catalog Service for the Web API, allowing users to search in an open way what is available. The Elasticsearch catalog does not host this API, but is very fast, which is the reason why we decided to also support this. To start, a user looking for data on the web will search in a catalog to see what is available. Search is usually done by typing in well-known queries such as flow, time, area IDs. The results of the metadata are then returned to the user for him to analyze and evaluate how interesting these records are. The metadata returned by the ForecastBroker contain direct links to the Threads server, allowing the user to download the available data. I will demonstrate this now using a use case. What we see here is the very basic user interface of the GeoNetwork search catalog. The first use case will be to search for observed flow in the Rhine River for a period of somewhere in 2015. What we do as user is type, we are interested in Rhine, we are looking for observed data and also flow. When are we interested? In what period? We are looking for data with a temporal extent ranging from the 1st of January 2015 to the 1st of December 2015. When searching, GeoNetwork returns 1,631 records. It's possible to refine this search by adding more search criteria. Looking at one specific metadata record, we see what it contains, for what period it is valid, and for us most importantly, the links to the actual data. Here we have a link to the metadata and also two links to the actual NetCDF files containing the raw data. Another use to look for forecast data. In this use case, we will look for forecasts of water level data produced for the Rhine River by the SOBEC model. In this search query, I have typed Rhine. I'm looking for simulated time series. I'm looking for water levels and something with SOBEC. As you can see, because everything is a text search, sometimes it is necessary to add wildcards. Furthermore, to reduce the number of results, I will restrict the search period. For the month September. This query returns 74 results of simulated data. Again, we have the metadata and links to certain data files. This demonstration shows how a human user would interact with a catalog looking for data. What is often the case is that instead of a human user, there are machines going through the internet looking for information. The process is more or less the same, but a machine is not as capable as a human to sift through metadata looking for what is interesting or not. However, the advantages of machines opposed to humans is that they can handle large quantities of data in a very short time. In the next example, I will show how we have implemented the machine search abilities in a product called the FEWS system. Here we see the FEWS software. We see in the map measurement locations available along the Rhine River. Behind the screens, first we will select some locations for which we want to retrieve data. We select observations as we did in the previous use case. We select some location points for which we are interested. Then we select what we're looking for, in this case, water level. It can be seen that for the current period we do not have any data available. Behind the scenes now we have our software scrolling through the catalog looking for information. If it finds metadata, it will enable a download button allowing us to immediately access and view the data. In the second use case, we look for forecast data. Forecast data is different than observed data in that you do not always have only one single measurement at one point for one location. In the previous example, I showed you how we can retrieve observed data from the catalog using an automated process. In this example, I will now receive forecast data from the catalog using the automated process. The process to reload the forecast data is different than the observations. Here we make a selection of the area. We select the period of time for which we want to look for forecast information. We look for the type of information. Voorspellingen is the Dutch word for forecast. And we have our software look in the catalog to see what it returns. From the results we can select some forecasts we are interested in, and we could download these into the system. We could check the logs to see that everything went well. And then we could go to the forecast manager and look up the data that we just downloaded. Let me see if this is the same. The first and second. We open the forecasts and then select what time series we're interested in. Here I select flow and water level at the location Lobit. And when we select the correct period, the forecasted data becomes available. So to round things up, I go back to a previous slide and try to summarize. What the ForecastBroker does is it does not provide you an app to search. It provides a means for you to store your data and be able to search and retrieve it again through means of open APIs. Thank you very much.